Today's lesson on 1-5 has a lot of vocab for different angles. So make sure that you write these things down and go back and review if you need to. Here we go. So this first piece of vocab here, adjacent angles. When we're talking about adjacent angles, we're talking about two angles who share a vertex and a side. And I'm just going to write that down. The book has more in terms of the actual definition here. I'm just going to explain it because I think that the picture and the explanation will be good enough. So here we have one angle. An adjacent angle is going to share the same vertex and it's going to share one of the sides. But what they're not going to do is they're not going to overlap. So this angle 1 and this angle 2 would be considered adjacent angles. They share this side and they share that vertex, but they don't share any points on the interior. If you want to just maybe make a little note of that, they don't share interior points. They don't overlap each other, if you will. And then a linear pair. A linear pair is a type of adjacent angle. A linear pair is, they are adjacent angles who also form a straight line. So the way the book words this definition is it says whose non-common sides are opposite rays. And you have to remember from that previous lesson what opposite rays are to have this make sense. I'll just write down that they are going to form a straight line. And that's why they're called a linear pair. You see that word line in the word linear. So when I draw this, what I do is I start by just drawing a straight line, and then I will draw that common ray kind of going off of that. So hopefully you can see here we have these two angles, but their non-common side, the side that they don't share, they form a linear pair, or they form a straight line. So these two examples, angle 1 and angle 2, those would be a linear pair. They are also adjacent, but not every pair of adjacent angles has to be a linear pair. Like you see up here, these do not form a straight line. And lastly here we have vertical angles. Vertical angles are non-adjacent angles that are formed by intersecting lines. And when you have vertical angles, they will be the ones kind of on opposite sides. I think about them being like across from each other. If I draw these two lines that are intersecting, the vertical angles would be like right here and right here. So when you have those intersecting lines, they're directly across from each other. I could write that angle 1 and angle 2 are vertical angles. There's always two pairs of vertical angles if you just have two lines that intersect. 3 and 4, because those are kind of directly across from each other, would be vertical angles also. We have these cheerleaders here. You can see that there are actually several different angles. We have, angle 1, 2, 3, 4, 5, and 6, but then we also have like combinations of those that we can talk about here. So the way that they want you to do this is not to use those little numbers that I wrote in, but to actually use like 3 letters to name those angles. So that's what I'm going to do. And the angles that I come up with, these are not maybe the only correct one that you could come up with also. So this first one, they want us to have 2 acute adjacent angles. So I'm going to find one of the acute angles. Let's talk about this one here. We have angle OJN. Well, the other one also has to be acute. So let's use this angle here. Do you see that they share this side JN? we can talk about angle NJM. So that is one example of two acute adjacent angles. Another way you can tell is they have the same vertex and they share this side, JN. If you didn't have kind of that overlap, you would know that this is not correct. Two obtuse vertical angles, remember the vertical angles are the ones that when you have like an X, they're straight across from each other. So what I like to do sometimes is draw that X in first. This whole angle, so we're talking about angle HJN, this angle here would be vertical from this angle here. That is angle KJM. And it's okay if you have these in a different order or if you have like the MJK, but you do have to have those two. That's your only pair of obtuse vertical angles. And then the last one here, a linear pair, there are several correct ways that you could define these. What I'm going to do is I'm just going to draw one of these two straight lines. And I'm going to maybe draw the one that most people would not notice. I'm going to draw this angle here. So one example of that could be saying that angle NJO, so NJO, that's this one, forms a linear pair with angle OJK. So notice that both of those two form that 180-degree angle. Once in a while, I have a student say they're looking at like this one and that one, and they say, well, it forms the straight line here. The only problem is those are not adjacent angles because they don't share a common side. So linear pairs have to be adjacent angles. This is one out of several examples that could work for that. Hopefully you've seen these other words before, complementary and supplementary angles. Complementary angles are two angles whose sum is 90 degrees, and supplementary angles are two angles whose sum is 180 degrees. I'm going to pause here for a minute. I remember when I was a student always kind of forgetting which one's which. One thing that always helped me was to remember that C comes before S in the alphabet. So I remembered 90 comes before 180, and that's the way I would remember it. I also have heard that if you had Mr. Putnam in 8th grade, shout out to Mr. Putnam, he would say to compliment somebody is the right thing to do. And if you can remember right angles or 90 degrees, that might help you out there too. So we need to remember that sum means that they add up. So complementary angles, what we're going to do is we're going to add the two angles up and it's going to equal 90. They may be adjacent angles. Like if you know that this is a 90-degree angle, these two angles here would add up to 90, but they do not have to be adjacent angles. We could have, this angle, let's say this angle is 60 degrees, and we have this angle here is 30 degrees. Well, those would be non-adjacent complementary angles. So it's not like it has to be one or the other. Well, I guess it does have to be one or the other, but it's not like it always has to be like this or always has to be like that. The sum just always has to be 90 degrees. Supplementary angles, what I'm going to do is I'm going to write out that they are going to add up to equal 180 when you have those two angles. And just like complementary, they may be adjacent to each other. So you could have these two angles are going to add up to be 180 degrees. Or, maybe you just have two 90-degree angles and they're not necessarily adjacent. These two angles would add up to 180 also. So going down here, this is kind of an algebra example. If people are going to struggle, sometimes they struggle with how to set up these algebra examples. So I'll walk you through this one and we'll practice more like this in class. It says, find the measure of two complementary angles if the measure of the larger angle is 12 more than twice the measure of the smaller. So I have a couple things going on here. I am going to have to write an equation, and I'll show you how I like to write those equations. So I know that the two angles are complementary. I am going to set that up as something plus something else is going to equal 90. and these are my two angles. Then it tells me here that the larger one is 12 more than twice the smaller. So I don't know either one. I am going to have a variable. Let's say my variable is x. So I'm going to say that the smaller angle is x. Well, if I use y for the larger, I won't be able to solve this. But what I do know is I know that the larger is 12 more than twice the smaller. So 12 more than twice x. Well, you should have practiced stuff like this in algebra where you remember like more than means that you're going to add to it. Twice x would be 2x. So 2x plus 12 would be the larger angle. The smaller angle is just what I don't know. We don't know either of them. And that's going to add up to equal 90. I'm going to solve this, and then we'll go back and answer the question. So when I solve this, adding my like terms, I get 3x plus 12 equals 90. I can subtract 12 from each side. So 3x equals 78. And then I'm going to divide them each by 3. There's the bell again. So 78 divided by 3, x would be 26. And remember, that is what the smaller angle is. So 26 degrees is one of the two. The directions say find the measure of two complementary angles. I always like to take that and plug it back in. 2 times 26 plus 12. So when I do that, I get 64. And then as a double check, what you could do is you could just add those up, and they should add up to equal 90 degrees. So I have all the information here that I need for that. I do want to really quickly point out, remember when you have, if it would have been like 12 less than twice the number, then you need to make sure that you are subtracting 12. So if this would have said 12 less than, you would have had 2x minus 12. Just a little rule from Algebra 1 that hopefully you can remember. Okay, I know I don't have the titles for these. I wanted you to add them on. One thing you need to know about vertical angles. Vertical angles like these two here are going to be congruent. They're going to be the same measure. So when you have problems that deal with these, let's say, for example, I have something like this is 3x minus 12, and this one here is 2x plus 24. And I wanted to solve that for x. Well, congruent just means that they're equal. What I'm going to do is I'm just going to set those two things equal to each other. And then I can solve it. So solving for x here, I'm going to subtract 2x from each side and add 12. If I do this too fast and you need to pause it, go ahead and do that so that you're not, bored with the algebra work or the algebra work goes too fast. Okay, so that's what x is. If I did have to answer the question for like how many degrees those angles are, I could always take that and plug it back in. Just remember that things don't have to be drawn to scale. If I take this and plug it in, 2 times 36 plus 24, let's see, that's going to be 96 degrees. If I were you, I would take it and plug it in here also, just as a good double check, so that you can make sure that you maybe didn't do like some algebra wrong or something. So that would be 96 degrees also, and since vertical angles are supposed to be congruent or the same or equal measures, I would feel pretty confident with my answer for that one. If you have a linear pair, however, these do not always have to be congruent, as you can see here. They could be, but they don't have to be. Linear pairs are always going to be supplementary, meaning that they're always going to add up to be 180 degrees. So if I'm looking at like this example, let's put some numbers in here for algebra. Let's say that this one is, let's go with 3x minus 10, and this one here is 2x plus 20. And I want to solve this for x. Well, what I can do is I can set 3x minus 10 plus 2x plus 20 equal to 180 degrees. And a mistake students sometimes make is they just want to set these equal to each other also. Well, you got to pay attention to like the fact that that won't always be the case. Solving this, I get 5x plus 10 equals 180. Subtracting 10 from each side, I get 5x equal to 70, or 170, and then I can divide each side by 5. So x equals 34. And depending on what the question's asking you to do, that might be the last step. If the question wanted you to find those angle measures, you could always do that by plugging them back in. So 3 times 34 minus 10, and then 2 times 34 plus 20. And again, these don't have to be drawn to scale, but you can see that those are supplementary. So this next word, perpendicular, what this is referring to is lines or segments. It could always be planes also that intersect at a right angle. And if it intersects at a right angle, that's going to mean that it's going to be 90 degrees. So when we're looking at pictures for this, if they say it's perpendicular, or it could even have like a little symbol, the symbol for perpendicular looks like this, or you may see like the little kind of box in the corner of the angle. That would also let you know that things are perpendicular. So it says here we want to find x and y so that PR and SQ are perpendicular. So that would be these two line segments here are perpendicular. Well, that would make all of these angles right angles, or if they're right angles, like in the case of these two, these would be adding up to be 90 degrees. So both of those together are forming that right angle. So those two smaller ones would be complementary. So let's solve for x first. That one's a little more challenging, hopefully not too bad though. I can add those two up and set that equal to 90. So 7x plus 6 equals 90, subtracting 6. So 7x equals 84. Or when you divide each side by 7, you should get x to equal 12. For this one here, it's just referring to this one angle, PTQ, and that angle all by itself is 90. So you could add 2 to each side. So 4y equals 92, or when you divide each side by 4, y equals 23. And I know this is the long section, almost done. There are a few things that we need to make sure we can talk about, things that can be assumed and things that cannot be assumed. So I'm not going to read through everything here, but I do want to let you know that we can assume things are coplanar, meaning if they're all drawn in the same plane, they are. Things are collinear, meaning like if it looks like they're in a straight line, they are. And that's kind of like the biggest one here that you need to know that you can assume, because that lets you assume that things are linear pairs and supplementary. Otherwise, we'd have like really long drawn out directions. So we can assume that fact. We can also assume like things are in between or in the interior. Things don't have to be drawn to scale, but you know, if they're going to put this point M here, it's going to be someplace on the interior around here. It can't be like M is like over on this side of that ray. Things that you cannot assume. This is probably like the bigger thing. You cannot assume that things are perpendicular. They have to be labeled either like in the directions or like over here it has that little box. If that's not there, you cannot assume that that would be 90 degrees, even if it looks like it. You cannot assume congruent angles. Those also have to be labeled in order for you to know it. And you cannot assume congruent segments either. Okay, so just because things look congruent or things look perpendicular, you don't know that for certain. So looking at these two questions, I know these are kind of weird questions, but the question would say, like, do you know this? Can you assume that these are supplementary? So looking up to this picture, I'm going to find GHL. So GHL is this angle, and angle LHJ. So LHJ, can you assume that those are supplementary? And the answer to that is yes, you can assume that. You can assume things are supplementary as long as they're, in the picture, and they should be, because that looks like it's a straight line. For the next question, the last one here, it says, can we assume that these are adjacent angles? So it says angle GHM and angle MHK. So MHK. So can we assume that these are adjacent angles? The answer to that is also yes. We can assume adjacent angles. I guess maybe I'll throw in one more here because you didn't have any that you cannot assume. Looking at this picture, could I assume that HM is congruent to segment HL? And they look like maybe those are the same length, but the answer to that would be no. You can't assume congruent segments unless, of course, they're marked. So I hope this helps. We have a lot of stuff from this section to go over, and we'll be working on this in class.